How to use Hsrp to provide redundancy in a multi-homed BGP network. This is what we are going to talk about in this video. So obviously this is from cisco.com, cisco.com, and I actually did this lab, if you will. So I have this topology in DNS3. So yeah, this is the network diagram which I created here in GNS3. So it's actually almost the same, uh, of course, except the interfaces. So yeah, so this document describes how to provide redundancy in a multi-homed BGP network where you have connections to two separate internet service providers or ISPs. In the event of a failure of connectivity toward one ISP, the traffic is rerouted dynamically through the other ISP with the BGP AS path. So AS path prepending command and HSRP or hot standby router protocol. Of course, this is the prerequisites, which is yeah, so just talking about how to configure HSRP, and you have knowledge of BGP best path selection algorithm, and of course configuring BGP as well. So the objective of the configuration in this document is to achieve this network policy. So this is number one. All outbound traffic from hosts on network. Uh, this is the network 192.168.21.0/24, and destined to the internet must be routed through R1 to ISP A. So in my case, it is R1 to ISP1. However, if that link fails or R1 fails, all outbound traffic must be rerouted through R2 to ISP2 and then to the internet without manual intervention. And number two is all inbound traffic destined to the autonomous system AS100 from the internet must be routed by through R1 to R1 to R1 or ISP1 through ISP1 R1 connection or path. In the event that the link from ISP1 to R1 fails, the inbound traffic must be automatically rerouted through ISP2 to R2. So this path here. Okay, these requirements can be met with two technologies, obviously BGP and HSRP. So this is how you configure it. So like I said, I have done the same configurations on R1 in my topology here, and this is the configuration. This is for the HSRP, and this is for the BGP. And in my case, I'm actually tracking, I have uh, I have a IPSLA. Let me just show it to you. I have a IPSLA, where is it? Configured, this here. And this IPSLA is basically pinging this IP address, which is ISP1, right? And of course, the source is gig0/0, which is this here, R1 LAN interface. Yeah, so R1 is actually eBGP peer with ISP1 and iBGP peer with R2. As you can see here, this is our no, this is R2 and this is ISP1. And this is of course the configuration for R2. So same configuration or Hsrp configuration and same BGP configuration. So basically R2 is IGP, IBGP peer with R1, which is this config or neighbor statement, and it is ABGP peer with ISP2, which is this one here. ISP2 is of course in AS400 and ISP1 is in AS300, R6 is in AS600, and both R1 and R2 are in AS100. So let me just read this note. It appends AS100 to the BGP update sent to AS400 in order to make it a backup for the ISP1 to R1 path. So basically we are doing AS path prepending on R2. We are prepending AS path prepending 100. So it's the local AS number in this case. So I'm going to add this document in the description of this video actually, so you can take a look if you want. So verify. This section provides information you can use to confirm your configuration is correctly or is working properly. And this when you configure redundancy in any network, you must consider two things. One is the creation of a redundant path for packets going from a local network to a destination. So this is basically the outgoing traffic from a local network to the destination. So meaning from this host or PC1 to the destination. So our destination in this case is actually R6 loopback. Let me add that loopback IP address /32. Yeah, this is the loopback IP address. Let me just put it here. Yeah. And number two is the creation of a redundant paths for packets coming back from a destination to the local network. So meaning the inbound traffic. So packets going from the local network toward the destination. So this is again, the outbound traffic. So let us check the Hsrp configuration. So here, this is our Hsrp IP address 192.168.21.10. And if we are going to check that on R1, we can do this. Standby. Let me just show you the config first. Yeah, this is the config on R1. And let me just show you the config as well on R2. Oops. This here. So R1 has .1 IP address or 192.168.21.1/24, and R2 is .20, .2. And the Hsrp or a standby IP address is both .10 on both routers. And we are using preemption in this case. And R1 is actually the primary because it has a higher priority in this case. So I believe the priority or the default priority is 100. So R1 has priority of 105. So higher priority is better in Hsrp. So let me just do this command. And of course, this is also, these are the configuration commands, verification commands that we can use. So in this case, I'm using this particular command, which is, show in standby brief. So we can see that R1 is active and active is local, and this is the standby IP address, and this is the virtual IP. Let me go to R2 and do the same command. So of course, priority here is 105 and priority here is the default, which is 100. So state is standby, which is expected. Active is R1 and standby is local. Virtual IP is this .10. Yeah, and of course you can do this command as well, which will give you more details actually. Let me do that command. So here, state is active, virtual IP address is this, active virtual MAC address is this, Hsrp MAC address, and we are using version 1 default. And hold time is 3 seconds, hello time rather, and hold time is 10 seconds. Okay, preemption is enabled, delay is 16 seconds, active route is local. Okay, looking good. Standby router, priority 100, priority 105, configured 105. And we have a tracking object, which is this, state up, document 0. Yeah, this is a pretty good command actually. Let me do the same command on R2. Okay, we're seeing state is standby. Okay, looks good. Yeah, I won't explain everything here on R2. Okay, let me do this command. I think this is the same with the, oops, no, not Ethernet. It's actually this brief, standby brief. Yeah, it gives you the same output actually. So you can either use this or this, but this is more common command actually. Show standby brief. Easy to easier to remember, I think. Okay, so the show standby command shows R1 is the active Hsrp router because of the higher priority like we discussed earlier. Since R1 is the active router, R1 owns the standby IP or Hsrp address, which is .10. All IP traffic from the host configured with the default gateway to this routes through R1. So we have a single host actually, which is PC1. And if I go here, yeah, so I already did the command. This is the gateway, and you can see that this is actually, what is this? This is my MAC address, I believe. Let me just go to R1 to verify that. Not really familiar with this. I think this is what they call VPC, if I'm not mistaken. Let me just check again. VPCS host. So I'm not very familiar with this host or um, workstation or client, whatever you call it. So I'm going to R1 and do show IP ARP. So looking for this one here. So this is PC1. This IP address is PC1.100. Yeah, this is its MAC address, which is what we have here as well. Yeah, the same. So how do we, can we do Hsrp empty? Okay, let me ping my gateway and do the same, do Hsrp again. Okay, so as you can see here, our gateway is actually that, so the standby or HSRP IP address, which is 192.168.21.10, and this MAC address here, which is the version 1 as according to our output here. So let's compare. Yeah, looks the same, version 1. So HSRP version 2 has a different MAC address. Okay, next, if you bring the SO interface on R1, on router R1 down, the HSRP active router. So basically, it's saying that when we, so we are tracking the IP address of ISP1, and we are using IPSLA for that, and enhanced track object, enhanced track object. Yeah. Um, if we bring down, let me go to ISP1 and actually shut down this interface. Oh, by the way, before I do that, let me show you a command to verify that we are running tracking on R1. Yeah, so this is our tracking, track 1, and we have a delay of, we have delay up 5 seconds, down 5 seconds. So tracked by, yeah, HSRP, this is the local or the LAN interface. Not sure about this one though. This number 1. So looking good. How about our IPSLA? Statistics. Statistics. Okay, number of successes looking good. So I'm going to ISP1 and shut down this interface. And expectation is R1 should become active, I mean standby. I forgot to do a trace route. Let me do trace. Let's see if it still works. Yeah, so I was able to run trace before. Hold on. Oh, it used this path here actually. So yeah, so the gateway is actually R2 now when I did the trace route, and it's going through ISP2, which is this, you can see the IP address, .42.4, and gets to the destination. I guess it was too late, so I can, you know, um, I think it doesn't matter. We can still verify that R1 is now standby. So as you can see, the priority has decreased to 95, and active is actually R2 now. So standby, state standby, standby local. It just do the same command on R2. Yeah, so this is now the active, and standby is R1. Okay, so the going back to the document. So we have redundancy for our outbound traffic, and we also have redundancy for inbound traffic. So when I go to R6 and ping, now what trace route? Ping 192.68.21.100, it will use the ISP2 and R2 path, which is what's happening to, which is what traceroute is showing us. So that 64 disconnect this IP address here, that's 64.4 and R2, which is .42.2, and it gets to the destination, which is PC1 here. Okay, so we have verified that we have redundancy for our inbound traffic and our outbound traffic. So let me see if we can. Yeah, this is a good verification. So let me do the same command on R6. So let's see here. So yeah, so according to this, the path is, let me just show you the network topology. So the path is ISP2 and R1 or R2, sorry. This is because of this connection here is down, right? ISP1 and R2 connection is down at the moment. So yeah, so it's actually showing the same, almost the same output here, right? So local pref 100, which is, yeah, that's the default local pref value actually. So best. So let me go ahead and unshut that interface, which is gig 0/0, or no shut rather. So we expect that, hold on, did I? No, I should have unshut this one here. So if you can, I mean, we have verified that we have this two things in our network. So we have a redundant path for our packets going from a local network to a destination. So this is our inbound traffic, and we have redundant path for packets coming back from a destination to local network. So this is the inbound traffic. So we have achieved our objective actually, and our objective uh, is this. Yeah. So we see that BGP came up. Let me do show standby brief. I think it will take a few minutes. Okay, so now our tracking has come up. Let's see, let me do that same command again. Okay, standby, still standby. I think we just need to wait a few seconds. Still active. Okay, let's check. Can we check? IP SLA statistics. Statistics. Okay, latest operation return code. Okay, show track. Show track. Okay, reachability is up, but so preemption is actually enabled. Yeah. So show standby. Priority 105, which is correct. So R1 has, oh, okay. So yeah, it took a little while for R1 to become active again. So now we see from the logs that R2 has become standby, or yeah, standby, and R1 has become active. So yeah, we're back to our original settings. So yeah, so I forgot to trace route before actually shutting down, the connection between our ISP1 and ISP1 and R2. So I'm going to do that now. So expectation is PC1 will choose this route here, or path, ISP1 and ISP1 and R1 path. That's the expectation. Yeah. So this is ISP1, and this is the R6 gig 01 IP address. All right. So objective achieved successfully. So I'm really happy with the with this lab actually. So we were able to uh, verify that we have, redundancy with our inbound and outbound traffic. So, yep, that's it in this video. Thanks for watching.